In modeling, there are many situations where you need to express material properties using mathematical relationships. And here's the solution. Hi there and welcome. In this session, we're going to learn how to perform curve fitting in EES, short for Engineering Equation Solver. Simply put, we'll learn how to turn a curve into a mathematical equation, which is especially useful when you need to express various physical properties as fitted functions. Let's take a practical example. Suppose you want to describe how the density of water changes with temperature at 1 atmosphere pressure. To do this, we'll first generate a table of water density versus temperature, considering temperatures from 1 degrees centigrade to 99 degrees centigrade. We're focusing only on liquid water. Ice and steam behave differently and would need to be modeled with separate equations, but you can implement the same technique. I'll define the pressure as a constant, PO hash, and it is equal to 1 atmosphere. Tip: always pay close attention to units. Dimensional errors are a modeler's worst nightmare. Since temperature is our independent variable, the system isn't solvable yet. We have one more unknown than equations. This gives us 1 degree of freedom, allowing us to build a parametric table, then input temperature values and calculate corresponding density values. Next, we'll plot the data, and from the plot menu, select Curve Fit. This is where the magic happens. EES lets us choose from several types of mathematical models, or even we can enter a custom equation. Now, looking at the shape of our curve, it resembles a quadratic relationship, so I'll use a second-order polynomial. To check how well it fits, I click on Stat to view the fit statistics. An R2 value above 99% is a good sign, but we can go further. Switching to a third-order cubic polynomial improves the fit even more, often pushing R2 closer to 100%, which indicates an excellent match. Once satisfied, I check Mark Copy to copy the equation for use in other software or reports. I'll also compare the plot visually to ensure it aligns well with the original data. And just like that, we've completed a successful curve fit. Now, what if you only have an image of a curve? In that case, you can use WebPlotDigitizer to extract data points from the image and manually enter them into EES to recreate the curve. I've included a link to WebPlotDigitizer in the description, and there are plenty of tutorials out there to help you get started. As you can see, even though EES is a simple tool, it offers powerful capabilities for many common engineering tasks. Sometimes, your property might depend on 2 variables. In our next session, I'll walk you through linear regression, a useful technique for approximating multivariable relationships, as long as their behavior isn't too complex. Until then, thanks for watching, and I'll see you next time.